Hey there, STEM enthusiasts. Welcome back to the STEM Spark. I'm Courtney, the place where we ignite curiosity, creativity, and confidence in every learner through science, technology, engineering, the arts, and math. Welcome to a different view of my room. All right, we're going to jump in today with some really fun topic STEM experiences that are using what if questions and scenarios. So let's jump in. Let's see. These what if questions and scenarios challenge students and adults to imagine what could be different. How could we experiment with things and explore STEM concepts in a new and exciting way? So, by asking a what if question, it's honestly at the heart of all scientific discovery, of engineering and innovation. It's all there. Like, what if this were better? Breakthroughs stem from what if, right? And so it pushes us beyond what we know, what we currently are experiencing, and what we currently know, into the world of possibility, creativity, innovation. So, in today's episode, we're going to explore how those what if scenarios can ignite that curiosity, can deepen the understanding of concepts we're already learning, and inspire both kids and adults to think like scientists and engineers and a little outside the box, right? So, what is a what if experience, right? Simply put, what if STEM experiences invite us to question our world? It invites us to experiment with changes in variables or conditions to see what might happen. For example, what if plants could grow without sunlight? What if you built a bridge using only paper? What if gravity was twice as strong as it currently is on Earth? What would happen? These questions spark imagination, and it motivates hands on exploration. It also motivates some intrinsic questioning of, okay, what do I need to know in order to answer these questions, right? So, why do we use STEM questions, like what if questions, in STEM learning? So, simply put, what if STEM experiences invite us to question and experiment with those changes, those conditions, to see what might happen? Why do we want to use what if in STEM learning? So, the first reason, and to me, one of the most important, I think they're all important, so it's hard to put a cap on it, but this is very important for learning to take place. Kids have to think critically about things. And so it encourages critical thinking. It encourages kids to learn to predict outcomes, to test hypothesis, and to analyze the results and see what worked and what didn't, and how you could maybe shift it even just a little bit to get an even better result. All right, so that critical thinking component is vital for learning. It also inspires research. So, what if questions help students to think about, okay, what do I already need to know about plants and sunlight and how they interact in order to change this variable, right? And so they need that background knowledge. So they are going to start asking questions, whether it's about plants or sunlight, bridges, physics, gravity, space, all of those things. It helps kids to intrinsically desire to have that information so that they can solve the problem, right? And so I would encourage you, like, when you're in that step, to really encourage students to think about, what do you need to know? What are some questions that you're wondering about? That's a really low key way of having students think about, okay, what do you already need to know that you don't know in order to solve this, right? And so maybe just have them wondering, whether it's out loud or written. It's a great way to throw in some writing, right? Okay, so we can kind of inspire that ability and foster that ability to research and want that information. It also promotes creativity. And if you watch this series for any length of time, you know that creativity is a big thing for me. And so, in inviting those learners to think outside the box and to consider multiple possibilities, because for some of our learners, when we do things that only have one solution, it is intimidating, because if they don't get it, they feel like a failure and different things, which we are trying our hardest to get that out of them. And it's okay to fail, and success looks a lot different to different people. But having a question that doesn't have one right answer is a really fun way to invite kids that don't feel great at maybe reading or research or science or fact finding, to have an outlet to kind of harness those skills in a fun and more creative way. So I think that's really cool to have that. And then it builds resilience, right? So not every what if question, what if scenario, what if solution is going to work. And so it's okay. It's part of the learning process. It helps us to promote that perseverance mindset of, I'm going to keep trying even though this didn't work. And also redefine success as, well, this didn't fail because I learned this, or I walked away with this understanding, and I can apply that to my next round of thinking or experimenting. And then the last thing is, it connects concepts. It helps learners to see how different STEM principles interact in real and everyday life, right? And so bridging that gap between math and physics, or bridging that gap between literacy and plants, right? And so helping kids see that all of these things are connected, and we practice these skills because they are connected, right? And we use these things all throughout our lives. Okay, so now that we've covered why we do it, let's cover how we do it. So I'm going to just give you just kind of a rundown of the steps that I use in my classroom. So if you're doing this at home or in a classroom, it could look the same or it could look a little different. You do what works for you, right? So pick a STEM topic. It could be something you're already learning about. So if you're already learning about plants, that's great. If you're about to learn about plants, even better. Like, let them kind of think and wonder about things even before you delve into it. And then they're naturally going to be starting to get curious and things like that. So it could be great for any type of learning situation. Maybe your topic is physics, maybe it's biology, engineering, it could be chemistry. It could be something that you learned last year that you want to kind of revisit, right? And so, whatever it is, pick your topic, and then you can pose a what if question. I always love to hear what my students think. And so, even if I want everybody to do the same question, I could have groups or partners work together to create all the different questions, and then we vote on a favorite one. Or if you have the ability to let them do whatever question they come up with, even better, because they're now intrinsically motivated to really discover that thing, right? And so, anytime you can give them that opportunity, I think it just promotes more investment in their own learning, that intrinsic motivation, and then you get the buy in, right? Okay, so once you have the question, then you make a plan. And I will talk about this again. I've talked about it in past episodes, but planning is critical. So doing some further research on the topic, having them thinking about, okay, what do I already need to know in order to solve this, is really important. I think for research in my setting, I do some like book research. I've also done some like just online research, but my favorite is honestly, YouTube videos, because we are visual learners. And so anytime we can give students something that works really well for how they learn is awesome. And so I will frequently find YouTube videos that work. All right, so the next step would be to try it out. If you're doing an experiment, gather the materials you need and experiment, observe, take some notes. You might even incorporate some math at this point by weighing or measuring or graphing. You could incorporate some technology by taking pictures or doing like YouTube short videos of them reporting on what's happening for each step of the process or for their observations or different things. And then the last step, which is critical for that critical thinking component, is reflecting. What happened? What worked? What didn't work? Was it what you expected to happen? What new questions do you have? And if you have time for them to like redo the project again, even better. This would be a great opportunity to add in some of those writing elements. So if you are working on writing or that is a part of your curriculum for homeschool, or if you're in a self-contained classroom, then incorporate some writing about the experience. And then the last thing we're going to talk about is an example. So I'm going to jump into the bridge building. So paper bridge. What if you could use paper to hold something heavy? Is a question I could pose. Another question would be, what if you try to build a bridge that held a book using only paper and tape? What if you built a paper taller tower than the table without using glue or tape? Right? So your question is going to base on your level of students, their level of background knowledge, and their ability to kind of comprehend the concepts of what you're doing. And so you could do the same project with a young student and an older student. So let's say you have a room with a third grader and a sixth grader. You could both do paper bridges. They're just going to maybe answer a different question and have a little bit of a different process. Obviously, one may be a little more complex than the other, or the math component is going to look a little different, right? So it is great for scenarios like that, where you need something that they like different levels of learners can all do. I do this in my scenario because I teach different grade levels. So I'll have multiple grade levels working on the same project. It just may be tweaked a little differently based on their age, right? Testing different designs. So maybe they keep the paper flat, maybe they fold it up, maybe they roll it up, right? So have them test out what their design is. See which structure holds the most weight and discuss why that is. Why did this one work better than that one? Using a scale, anytime you can incorporate a scale, I think it's a great thing. I think too many students have not used measuring tools as much as maybe they should, or maybe they need to in order to be equipped to handle the different scenarios as an adult, right? And so pull out a scale. If it's digital, I use both the metric and the standard and talk about the differences. So things like that. You could use a tape measure to measure how tall the structure is, right? And so lots of different ways you can incorporate some math at this point. Graphing is a great way to do that. So if you have time to go back through the process and do something a little different, it's great. Next time you're curious about something or how the world works, or want to get kids and excited about STEM, just try a what if experience. It's a simple way to turn everyday questions into meaningful learning experiences. So, thanks for tuning in. Don't forget to follow the show, leave a review if you're loving it, and share it with a fellow educator, parent, or STEM enthusiast. I'd love to hear your favorite what if questions and scenarios. Drop them in the comments. I look forward to reading them. This is Courtney, and you've been listening to The STEM Spark, where curiosity sparks creativity. Bye.